My next two examples have roots that are fractions. Now, I'm not saying that my quadratic equation couldn't have fractions. In fact, let's give an example right now. Let's say 2/3 x squared plus 3/4 x plus 5 happens to equal 0. But it would be a lot easier to factor if a, b, and c were integers. And so one of my expectations are that you will be able to write a quadratic equation given its roots using integers. So what would have happened if I would have had the quadratic expression down here? What I would have needed to do is find probably a common denominator that I could then multiply to each piece, so that common denominator being 12. I would distribute it to each of the pieces, starting with the quadratic, where I would get 24/3 x squared, which could then be simplified as 8x squared. I could multiply the 12 to the linear term, coming up with 36 over 4x, or plus 9x. Distribute the 12 to the constant, that's just simply 60. And then also distribute the 12 to the equal 0. And the nice thing is anything times 0 still remains 0. So if I could come up with an equation of 8x squared plus 9x plus 60 equal to 0, this would be significantly easier to factor. Now, it would be a lot easier if I could do that immediately with the roots that I have. So if I have one root being x equals -3, it's not going to take me long to figure out that if x plus 3 equals 0, one of my factors should be x plus 3. On the other hand, if I have a root that's a fraction, in this case -1/4, I could go x plus 1/4 equal to 0, and then I could technically use that as a factor and multiply them together. But then I'm going to come up with some difficult work for foiling, which then I would also want to distribute at the end to kind of clean it up. So how about, before we actually do that, why don't we simplify the expression up here by essentially doing the same trick I did over here and multiply by the common denominator 4. If you distribute the 4 to the x, you'll get 4x. If you distribute the 4 to the 1/4, you'll get plus 1. And if you get 4 and distribute it over to 0, you get equal to 0. And you will find out that it's going to be a lot easier to use the factor 4x plus 1 than x plus 1/4. And now I can FOIL those terms out. And I'm just going to work out that quickly. 4x squared. Then comes x for the outside terms, plus 12x, which is my inside terms, plus 3 equal to 0. And I can come up with the final expression, or final equation specifically, 4x squared plus 13x plus 3 equal to 0. Not only is it easier to FOIL, but it is also nice and clean, and then could be factored again if necessary. So let's look at the second example. If I have x equal to 7/6 and x equal to -5/2, first I would come up with x minus 7/6 equal to 0, and I would also come up with x plus 5/2 equal to 0. But what I would do is I would want to multiply this first equation all by 6, and so I could come up with 6x minus 7 equal to 0. The second equation, I would want to multiply everything by 2, and I can come up with 2x plus 5 equal to 0. So now I can take the factors 6x minus 7, 2x plus 5. I could then FOIL those together, coming up with 12x squared plus 30x minus 14x minus 35, make that equal to 0, and I can come up with a final quadratic equation of 12x squared plus 16x minus 35 equal to 0. So, as you find quadratic equations, we're going to make it the expectation that your A, B, and C are integers. And that's how you would go about doing that.